students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today, I will discuss about the topic that is called as landfill gas collections and its treatment. So, in this lecture series of this solid waste management subject, now we are discussing the module about the transformation of waste and its final disposal. So, for this transformation and final disposal of waste, we are coming at the point of landfill. So, previously we have discussed about the landfill, types of landfill and how landfills has been made. Like landfills is a kind of engineered way of putting waste in the outskirt of city. So, and in the landfill, we have already discussed about the actually many type of waste are there. Many waste that has been generated from a city has been disposed into the landfill that will be present in the outskirt of the city. So this landfill will be having lots of gas will be there and lots of mixed gases will be, mixed type of waste will be there. So this landfill will be having mixed waste. So with mixed waste, after when the time has been passed for a landfill, there will be a chemical reaction inside onto the landfill. Chemical reaction is going to going on the landfill. So with this chemical reaction, first is the when the oxygen will be available. So at that time, aerobic kind of reaction will take place. When the all oxygen has been consumed by the microbial activity, then the next phase will be start. That phase is called as anaerobic digestion process. So during the anaerobic digestion process, the landfill into the landfill, in the anaerobic digestion phase, it will lead toward the production of methanes also, because anaerobic chemical reaction will take towards the methanogens step will be there. So from the methanogens steps, methane will be produced. So we are at the point where we are discussing about the landfill gas generation. So in this way, during this anaerobic reaction onto the landfill gases, anaerobic reaction, methane has been produced. Methane, CO2, H2S, this type of gases has been produced, but methane is the main gas. So production of methane from the landfill is a point of concern. So that's why we are dealing with the topic that is landfill gas generation and then mechanism. So by which mechanism this landfill gas has been generated. So because of this anaerobic reaction only or some other biological decomposition process, many process will be happens onto this landfill. Because of that one only this methane production takes place. So it is like a gas generation mechanism and gas transport mechanism. For this landfill, for this methane, two type of mechanism will be there. First is the gas generation and then transportation of the gas mechanism. So there are three primary causes of this landfill gas generation. First is the volatilization, biological decomposition and chemical reaction. First reaction takes place is the volatilization. We'll discuss about all these things in detail in the coming slides. Then biological decomposition. Biological decomposition will be same like a anaerobic decomposition process. And then next is some chemical reaction will happens inside this landfill. So first we'll discuss about what are the factors that will be responsible for this landfill gas generation. So for landfill gas generation, these are some important factor they are responsible. So first thing is the composition of waste, like which type of waste will be there. Either it is a food waste, organic waste, or construction and demolition waste. Next is the temperature of the landfill. All these are the physico-chemical characteristics of the landfill. Physical condition. So in physical condition, the point is there is the temperature. Temperature will come. Next is the moisture. Next is the pH. Next is the atmospheric condition. Then the landfill cover, like which type of soil is there, soil or manure. Then waste density and the waste age of the landfill. is of the landfill. So all these steps, all these are the important factors that will determine the landfill gas generation, like the composition of waste, total temperature, the moisture content, pH content, and all the environmental condition like atmospheric condition like rainfall, then contour mapping. So all these factors will determine the landfill gas generation rate. It will be contributes toward the landfill gas generation, like the age of the waste, density of the waste, landfill cover, atmospheric condition, pH, moisture, temperature, and the composition of the waste. So how this transport can be takes place in a landfill. So the transport of landfill gas occurs by the two principles. First is the diffusion and advection process will be there. So diffusion and advection process. So diffusion is the movement of gas, like the transport mechanism. Movement of gas from inside the landfill is movement of gas from the landfill to outside, and because of that only it will create too much nuisance in the vicinity of this landfill plants. So the diffusion means like the diffusive flow of gas is in the direction in which its concentration and the concentration of volatile constituents in the landfill gas will almost always be higher than that of the surrounding atmosphere. So the diffusive flow of gas is like it is in the direction, so it will be sometimes what happens, the concentration decreases and the concentration of any volatile constituents in the LFG like landfill gas formation will almost always be like higher than that of the surrounding atmosphere. So because of that, diffusive flow will come, diffusion takes place, and it will be in the direction in which its concentration decreases. So diffusion will be there. Diffusion is like that, it is a movement or it is the flow of gas into the direction where its concentration is decreases, and the concentration of a volatile constituents of landfill gas will always be higher than that of the surrounding atmosphere. Obviously the concentration of the landfill gas is always be higher than the surrounding atmosphere. So the concentration inside the landfill is higher than the surrounding atmosphere. So because of the diffusive flow only, the gas will flow in the direction outside. The gas will comes toward the atmosphere. It is going to be mixed with the atmosphere. So because of diffusion, this diffusive flow of gas, this is the nature of the flow of gas. Gas will flow in the direction in which its concentration is going to be decreases, and the concentration of a volatile constituents in the landfill gas will always be higher than that of the surrounding atmosphere. And the concentration gradients between the surface and the interior of the landfill, and thus it is going to promote the migration of vapors to the surface. So like that, what happened, the concentration gradients between the surface and the interiors of the landfill, the concentration gradients between the surface of the landfill and the interior of the landfill, it is going to promote the migration of vapors to the surface. So it will be promoting the migration of vapors towards the surface. And the geomembranes, next is the geomembranes are there. So geomembrane in the landfill will going to cover, and it will significantly reduce the diffusion, because the geomembrane prevents gases from diffusing to the atmosphere. So because of, to stop this diffusion, this geomembrane should be added. Geomembrane is added. So what this geomembrane is doing, it is a cover to the landfill. It is the cover on the landfill. It is the cover on the landfill that is going to be reduce the diffusion. That cover will reduces the diffusion because the geomembrane will prevent gases from diffusing to the atmosphere. Next is like the advection will be there. Advection is again one concept of the movement of gas. So in this, what happened, the rate of gas movement is generally orders of magnitude faster for advection than for diffusion. So the gas movement magnitude will be faster for the advection than for diffusion. So what happened, the gas will flow from high pressure to lower pressure. Here again, this will happen from gas will move from high pressure region to low pressure region. From high pressure region, high pressure to low pressure. Gas will move from high pressure to low pressure region. And in the landfill, advection forces results from the production of vapors from biodegradation processes, chemical reaction, compaction, or an active landfill gas extraction system. So this extraction force is because of the production of vapor by the biodegradation process, all by the microbial activity only, all by the biological decomposition process only. So the chemical reaction compaction on an active LFG extraction system. So the landfill, its advection force results from the production of vapor from biodegradation processes, chemical reaction, compaction, or an active landfill gas extraction system. Next is the permeability. So permeability of waste has a very large influence on the gas flow rate and gas recovery rate. The permeability of the waste, waste permeability. So coarse grain waste exhibit large value of gas permeability and more uniform gas flow pattern. And fine grain source heterogeneous waste are characterized by small values of gas permeability and gas flow pattern that are not uniform. And geological condition is it must be determined to estimate the potential for offsite migration of gas. So after the advection, next factor is the permeability. So waste permeability is having also playing a very important role in the flow of gas rate and gas recovery rate also. So coarse grain waste, like the waste which is coarse grain, that will be having a large value for gas permeability. Coarse grain waste will be having larger value for the gas permeability and more uniform gas flow pattern. So gas flow pattern will also be uniform, and fine grain so heterogeneous waste. And if the waste is fine grain, and coarse grain, so this fine grain waste are characterized by some small values of gas permeability and gas flow pattern, so that will be not uniform. So two type of waste, the permeability of waste will be first is the coarse grain waste. So coarse grain waste will be having more uniform gas flow pattern, and fine grain will show heterogeneous waste, and it can be characterized by the small values of gas permeability. It will be characterized by the small values of gas permeability and gas flow pattern that are not uniform in nature. So like that, geological condition, it should be also determine and estimate the potential for the offsite migration of gas. And next is the depth of groundwater. Groundwater is like the underground water, the water table surface. The water table surface act as a no flow boundary for gas. So the water table surface can be act as a no flow boundary for gas. So during the design process, the well construction equipment and for the potential for water table upwelling should be evaluated. So during this designing of well for water table surface, designing of waste will be there. So during the designing of waste, the water table surface will be it should be well constructed requirement, and the potential for water table upwelling, it should be evaluated. And the upward rise of water table towards a vacuum well screened in an unsaturated zone. The upward rise of the water tables towards a vacuum, it will be well screened in the unsaturated zone. So the upward rise, the rise of water table towards the upward, it will be screened in the unsaturated zone. Next is the man-made feature. So for man-made feature, in some instances, what happened, the underground utilities like the storms and sanitary sewers or the backfill that surrounds these features may produces short circuiting of airflow associated with an active landfill gas collection system. So in some instances, what happened, the underground utilities like storm and sanitary sewers or the backfill that will surround these features, it is going to produce short circuiting of airflow that will be associated with an active landfill gas collection system. Landfill cover and liner system. So the landfill cover system, it will be consist of a vegetated surface component. This landfill cover system consists of a vegetated surface component, a drainage layer, and a low permeability layer that will be composed of one or more of the following, like either geomembrane, geosynthetic clay liner, or compacted clay. Geomembrane, geosynthetic clay liner, or compacted clay. So, two are there. First is the man-made feature. Next, we have discussed about the landfill and liner cover. So, it consists of a vegetated surface component like a drainage layer and a low permeability layer that will be composed of one or more of the following, like geomembrane, geosynthetic clay liners, and or sometimes the compacted clay. Compacted clay will also be there. So geomembrane, first we will discuss about the geomembrane. In the cover system, it will prevent the intrusion of air into the waste. So the intrusion of air into the waste, so that air will not enters into the waste. So it will be calculated with the barometric process pressure. Barometric pressure is like the amount of gas escaping from the landfill surface changes as the biometric pressure changes. So the amount of gas escaping from the landfill surface change as the barometric pressure also change. So the passive landfill gas collection system increases in the atmospheric pressure. Because of atmospheric pressure, there is a decrease and it causes a decrease in gas flow from the landfill because the pressure differential between the inside and the outside has been decreased. So in this way, we have discussed about the landfill gas collection system, and it increases in the atmospheric pressure and decreases in the gas flow from the landfill because the pressure differential between the inside and the outside is going to be decreased. So you can see that this is like a active gas collection system. So in active gas collection system, the atmospheric air intrusion through the landfill cover during the periods when the biometric pressure is rising. So you see this is the gas well picture. This is the waste fill and gas drainage layer will be also there. So gas drainage pipes are there, like this pipes has been installed. This pipe are the gas drainage pipe with some separation membrane is also there. Then cap sealing layer. Above that, cap sealing layer is also there. Then surface water drainage will be there. Then here you can see that separation geotextile will be there. This is separate the geotextile. Geotextile is separating from this place only. So this is the topsoil, subsoil. Topsoil and subsoil and geotextile separation is also there. And surface water drainage is also there. Surface water pipe is there. You can see this is the pipe. And this whole layer is the cap sealing layer. Cap sealing layer will be there. Then gas drainage layer is also there. And this is the gas drainage pipes. And here we will fill the gases. So this is the complete picture of the gas well, which is represent the gas collection system. So the atmospheric air intrusion to the landfill covers during the entire period when the barometric pressure is rising. So now we'll discuss about the designing of gas wells. So performance question for the well like meter cube per hour per millibar. So larger diameter like approximately 900 mm is 50 only. It should be 50 only, 50 meter cube per hour per millibar. For vertical 10 to 30. For horizontal it will be taking as 10 to 50. And next we will take we will keep in mind about the site contaminants, like what is the contaminants available. Temporary capping like daily cover like manure or night soil or soil. Then permanent capping keeps out water and air. Permanent capping is the keeps out water and air and keep in gases and odors. Site lining to contain waste, leachate and gases. So these are like some site lining will be there that contains some waste, some leachates and gases. Optimizing the gas well operation. So you can see that this is the optimization of the gas well operation. So gas well in elevation, it is the picture, you can see that. And minimize the gas velocity. First we will minimize the gas velocity. So gas approaching the well make well diameter large. So when the gas is approaching the well, this will make the diameter large, maximize the effective length, and makes the gas well deep and keep it dry. Maximizing the effective length, it will keep the well deep and dry. And next is the provide contingency measures. So the connection, flexible connection, movement joints at well heads. So 3 points are there. First is the minimize the gas velocity, maximize the effective length, and provide contingency measures. So for minimizing the gas velocity, gas approaching the well and make the well diameter large. In this way, the diameter will be large and then the effective length will be maximized. So in this, what happened, the gas will keep it dry and will be deep and keep it dry only. And flexible connection like movement joints at the well head. So this is a picture of the gas well in the elevation. Next is the designing of pipe work. So pipe is specified by outside diameter and either pressure rating in the bar or a standard diameter ratio, SDR. SDR is equal to OD. OD means outside diameter and wall thickness. OD means outside diameter and wall thickness. So the standard diameter ratio is equal to SDR, and SDR can be outer diameter divided by the wall thickness. So for any landfill gas, typically the pipe should be 6 bar, 6 bar pressure, 6 bar of the pressure. So SDR will be 17.6. So gas will always gives pressure loss. Gas flow will always gives the pressure loss, and the loss in pressure like M bar for gas flow rate is Q through a smooth pipe of inside diameter estimated using P is equal to 60,000. So the designing a pipe is like it should be 60,000 Q square ID5. So this is the actual designing of the pipe, which diameter of pipe is required, what are the measurement of the pipe will be required, and the gas will always flow with some pressure loss, and landfill gas will be like 6 bar, and this is the actual description of the designing of pipe works. Now we'll discuss about the gas collection system. So gas collection system is 2 type of system will be there: passive gas collection system and active gas collection system. So in passive collection system, it will be installed during the active operation of landfill or after the closure of landfill. After the closure of landfill, the collection wells are typically constructed of perforated or slotted plastics, and it will be installed vertically through the landfill and they are installed vertically through the landfill to depth ranging from 50% to 90% of the waste thickness. So the collection wells are typically constructed of perforated or slotted plastics, and it will be installed vertically through the landfills to depth ranging from 50% to 90% of the waste thickness. It may also sometimes includes the horizontal wells that is located below the ground surface to serve as conducts for gas movement within the landfill. So it will also include the horizontal wells that is located below the ground surface, and it can serve as a conducts for gas movement within the landfill. So you can see that this is the passive gas collection system. This is the gas collection layers. Gas collection layers will be there. You can see this is the cap and topsoil. Topsoil is on this is topsoil, and cap is there. Then gas collection layers are there. This is vent has been installed. From there, gas will be collected. These are the layers which you can work as a passive gas collection system. And waste will be there. You can see this is the waste and topsoil. This is the picturization of the passive gas collection system. Through the vent, we can collect the gas, and the gas collection layer is also there. From within the gas collection layer, pipes has been installed, and below above this layer, above this surface, cap will be there, and this is the topsoil. So through the cap, by the vent, we can collect the methane gas and whatever the gas will be there. Then next is the active gas system. So in active gas collection system, it will includes the vertical and horizontal gas collection wells similar to the passive collection system. Wells in the active collection system should have valve to regulate the gas flow and to serve as a sampling port. So the well which is present in the active system will be having valves, and that valve will regulate the flow of gas and serve as a sampling port. And the sampling allowed the system operators to measure the gas generation, composition and pressure. So this active gas collection system will allow the system. This is going to measure the gas generation, composition and pressure. This active gas collection system will basically mainly include the vertical and horizontal gas collection wells that will be similar to the passive collection system. And wells in the active system should have valves to regulate the gas flow, and it can serve as a sampling port also. So this active gas collection system include vertical and horizontal, means the vertical as well as horizontal, both type of gas collection will be there. Both type of gas collection wells are there, and these are very much similar to the passive collection system, because the wells in the active system should have the valves, so they will regulate the gas flow and serve as a sampling port, because the valve has been made to act as a sampling port. And the sampling allow the system to operate to measure the gas generation, which type of gas has been generated, like CO2 or methane, or the composition of the gas, and the pressure of the gas also, how much pressure they are putting on the gas, and what is the actual quality of the gas in this active gas generation system. So we have a study about two type of gas generation system will be there in the landfill: passive gas generation system and active gas generation system. Okay, so you can see that this is a picture of this active gas generation system. You can see that you can see that this landfill waste, this is the landfill waste, this is the percolated and slotted plastic will be there. So you can see that here horizontal gas collection pipe is there, horizontal gas collection pipe will be there, and there vertical also. So horizontal as well as vertical, both type of collection system has been installed in this method, horizontal and vertical. And what it is there, what it is going, because how it is working. So this, you can see, this is the picture. Gas collection pipe will be there, and then gas extraction wall is also there. So from the ground surface, gas pipes are there, and gas extraction wells is there, both horizontal and vertical also. In this way the gas extraction well can be worked, you can see, and this will be act as a sampling port. So we can take the samples to know the composition of gas, characteristics of gas, and the types of waste also. And from this way only, methane can be collected, and that can be used for many purposes, like for electricity generation, for the generation of like some city, some electricity they will give, or sometimes biogas plant can work. So like this, gas can be collected. So on a landfill site, lots of methane gas can be generated, and this has been generated because of the mixed waste only, and because of the anaerobic condition has been created on the landfill site. So in this way, it will be create very nuisance condition for the normal people, normal local people. And this gas, this methane movement, either through the subsurface, or it can move by horizontal, it can move vertical also, it can move nearby to the surface area, or sometimes this movement will leads towards the residential area, and this will causes cracks on the walls. This methane sometimes causes cracks on the walls also. Cracks on the wall, this methane is causing. So because of, to avoid this type of problems, a well has been established on the landfill site, so that we can monitor, we can collect the gases, in a so you can utilize these gases for the electricity generation, like that. So now comes to the next point. This is about this active gas generation system. What happened, the vacuum or pumps, it will moves gas out of the landfill, and piping that connects the collection well to the vacuum. Obviously, vacuum is created inside that, vacuum is created, and this vacuum is causing the movement, gas movement out of the landfill, out of landfill. So this is a piping, and that connects the collection wells to the vacuum. So this will be going to connect the collection well to the vacuum, and from the vacuum the gas can move out of the landfill. And next point is that, like that, the size, type and number of vacuums required in an active system to pull the gas from the landfills will depends on the amount of gas that has been produced. So the size, type and number of vacuums required in an active system. So required in that active system to pull the gas from the landfill, and depends on the amount of gas that has been produced. So the how many number of vacuum will be required, what is the type of the vacuum, what is the size of the vacuum in an active system, so that it can be pull the gases from the landfill. It's totally depend upon the amount of gas that has been produced from the landfill. So to establish the vacuum, to put a vacuum on a landfill gas collection system, it will be based on the other features, other properties, like the size of the waste, the type of the waste, and the number of vacuum required, which size of vacuum will be required. And this all related with the landfills depends upon the amount of gas that has been produced. So this is a description about the active landfill gas collection system. Gas collection system is very much required in any landfill, because this methane is a very useful gas, because you can utilize this methane for the electricity generation. Otherwise, this methane will having many negative impact on the environment. It comes under the greenhouse gases, and it will contribute toward the global warming. So more number of methane has been generated from the landfill nowadays. Now I'm closing my lectures, and this is the references of some of the textbook that you can utilize for your study if you want to go depth study about these topics. Okay, so now I'm concluding my lecture. In this lecture, I have discussed about the landfill gas collection system, and what is the treatment system, and how this landfill gas collection should be done by the active method and by the passive method also, and how this gas movement can take place in a landfill. So if you have any queries, if you have any question regarding this lecture, you can write in the comment box, or you can mail me onto my given mail ID, shikha.pandey@gmail.com. You can mail me on my given mail ID. As for now, thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.